They're just not so obvious.
You don't get to see it.
Yeah, that's right. Except for Windows, it just doesn't tell you. Yeah, exactly. Windows doesn't tell you.
Actually, I like
This is journal. It's just that it checks every 30.
Every 30 mounts.
PostgreSQL doesn't do that.
Yeah.
And JFS doesn't do that.
Well, yeah, but JFS will just drop the volume out from underneath you.
That's bonus.
Yeah, it's a feature, right?
That's weird.
Feel confident. So Robert Tree, it works for OmniTI. They've got mad SQL skills. They even have a shirt that says it, so you got to believe it. He works for Jesus. And you're part of the dub team, a committer as an on the dub team, in fact.
Unfortunately, I'm committed too.
Well, they threatened me with it, but I don't have a G-board here, so.
Is that still on G-board?
It's still on G-board, that's why, yeah. We're working on that. We're working on that. Yeah. You've almost got everybody migrated off, right?
I've got
Most people. And then we got them all migrated to PG Foundry, and now we're moving PG Foundry and reinstalling from scratch.
Yeah.
In the PostgreSQL community, we always do it right the fourth time.
So I really don't have
Just
MVC
At least that's the first like 10 minutes of it.
Well, see, this is a prime example of why you need more I/O in PostgreSQL. It's just not enough I/O. I mean, you're writing to what, 5,400 right there?
This is why you need to have your laptop plugged in when it's running power to figure it out.
Oh, yeah. Might be a good idea. We're getting there. We're getting there. As a note about the conference, I was actually going to say this as part of my closing remarks, but since I have a little bit of time here. All the money that was for registrations and sponsors went directly to PostgreSQL. This entire conference was free to the community. And based on the great response that we see in this room and our sponsors, the community raised over $5,000 for this one day. So, and I will be soliciting more donations at the party.
$5 free beers.
$5 free beers.
Well, I'm going to start, because the first bit is just sort of a little Q&A and knowledge stuff. The talk itself is about partitioning on Postgres, and it's vertical partitioning, meaning staying inside the database, not doing like horizontal partitioning, seems to throw people, but it's about the actual partition setup that you get inside of Postgres on a per table basis. How many people here actually have used partitions in Postgres? Okay, a bunch of you. Hopefully you all like them. I find them to be nice, but there are some issues. So I work at OmniTI, and we're like a consultant type company, like most other companies that are in the Postgres realm. And we kind of use partitioning for a lot of different things. The one that most people care about is the one that I'll be talking about here. It's a terabyte size system, and it has a lot of data in it, obviously. We've done partitioning a number of different ways, and some of that still is living there. And we'll talk about different methods you can use for partitioning. Some things that might be relevant, I don't know. One of our tables has 1,700 partitions in it. That's our, it's not actually our largest table by size, but it's the most number of partitions. We have a table that's like, I think about 250 gigabytes worth of data in there, and it's partitioned as well. Hey, look at that. Don't look. A, B, C.
There's a camera pointing down at the scene.
Right on the keyboard.
So those are two of the things that we have going. So I mean, we've done a lot of partitions and had to sort of figure out a number of things in order to get that working. So we have over a dozen different, like fairly good sized partition tables inside that particular database. just because of the size and the scale of what is going on inside that one, it seems to make it the most relevant for when people think about partitioning and what they want to do with partitioning. So most of the examples you'll see here are sort of based on that knowledge. And also, we've been doing partitioning now for a couple of years, actually, based on stuff. So this is sort of. And then the largest table by row size is actually 2.5 billion rows in that table. I had to go look that up because you stop counting after you hit a billion.
So did you do count stars?
I did count stars.
Wow.
Count stars from only. And then I went and used PG class. And that's actually not the 200 gigabyte table either. So these, I think, are 3 different tables, these large ones that we have in there. So that's sort of how, I mean, those are the things that we were working on that sort of got us into partitions and we cut our teeth on learning it. So the things I wanted to kind of discuss today, it's not, I don't consider partitioning necessarily rocket science. It's a little loopy when you first get into it. Once you understand the basics of it, I think it's pretty straightforward. I think the docs steer you along in a number of ways. And so it's one of the reasons why I do this talk, to try to, I think, get people back on track.
You know what to do about that.
These presentations, I don't know.
Doc patches are always nice.
They are, yeah, but this one would be pretty extensive. So anyways, so we're going to talk about a number of things with partitions. Hopefully when you get done, you'll see like there can be some effort involved, but usually once you get things working, like you don't have to deal with it too much after the fact. So it's worth putting in that initial effort to get it working on your system. The first thing we'll start out with, we've got some the first thing I'll start out with is basically the question of asking yourself, why would you actually use partitioning? And there's actually a lot of cases where you shouldn't, that I think people try to jump into it. It is a very good tool, it's pretty powerful, and I'd say don't have any fear of it, but ask yourself a few questions before you get started. The first thing that you use partitioning for generally is going to be performance. As you probably all experience, as table size grows, you start to have performance issues in a number of different ways. I think most people are pretty familiar with that idea and that concept. Even with indexing, I mean, everybody's using indexing anyways, but at some point you're still going to get to a point where it's a problem. I usually toss out a number of tables over 100 million rows on fairly average hardware really become a problem, Postgres, where you really start to need pretty significant hardware to deal with that kind of stuff. And partitioning can help you get around that. You can also have data access patterns where you're really not always looking at all the data in the table. You only need a small subset. The classic example I like to use is a ticketing system where your recent tickets get a lot of activity. When they get created, they're updated, but eventually tickets tend to get closed. And then they might be looked at for a little while, but eventually you'll get tickets that are 2 years old, and nobody's really ever looking at those. So the access patterns of your data are generally focused on a pretty small range of data in there. And having these really large tables, you can split them up in different ways, but partitioning is one way that you might want to look into for splitting things up. Some of the other reasons, manageability is a big thing with partitions. This tends to go back to data size and table size. The larger your tables get, the harder it is to actually deal with them. The good example is the tables where maybe you have a 90-day window of data you care about. So you're inserting every day, and then at the end of the day, you're doing this big deletion job at the end for anything older than 90 days. And that works well if you're getting 1 million rows a day, but when you're getting 10 million rows a day, suddenly that deletion block, it really starts to take up a lot of time, starts to use a lot of system resources, and partitioning is a good way you kind of get around that problem. Also, the maintenance commands, they're also an issue, right? When you do a vacuum, and you can go back to that ticketing example where, maybe you have 10 million rows in your table, and you only updated or dealt with maybe, I don't know how many tickets you'd have in a day, but maybe 100 or 200, you still feel like you want to vacuum that table, you've got to scan the entire table. So you're vacuuming, 100 million rows for data that's only changed on, maybe 200 rows or something. And that just gets worse and worse the larger your table size grows. Right? So there's another case where you might want to look into partitioning, you might want to deal with that. Other things like clustering and reindexing and all those kind of system level things that you deal with as a DBA, those are all affected by table size. And all of those can be made easier if you're using partitioning on some level. So the last thing is sort of that idea of doing scalability with partitioning. And I'd say vertical scalability, again, we're not splitting across servers, but you can split partitions across like spindles. If you have different disk arrays that you can get set up, you can then put part of a partition on one, part on another. So it helps you address things in that way. Also just the idea that, again, I said like 100 million rows you can probably do on one server, with fairly general hardware. But if you need to get higher than that, if you're going to go to 1 billion rows in a table, in one table, it's just not going to work. So if you want to scale those numbers to really large amounts, you really have to have some kind of system to address that. And partitioning is a tool that Postgres tends to give to do that. So, talking about partitioning, there's not a lot of history to it. It really came around in 8.1 when it really started to get thought of as partitioning. There were people that were doing it before 8.1, and they were doing these things, and it's actually not all that much different than what we're doing now. Either creating tables, just individual segmented tables, and then putting like a view over top of those, or some people were using inheritance. One of the better schemes I saw, somebody was using set returning functions to query their data, and then the function had enough smarts in it to go and look in specific partitions and grab the rows and return those back. And it was sort of one of the better ones. The problem that sort of had was, ideally you'd like your partition table to act like a normal table from an application developer side. So if you have to use special syntax and function calls to get at it and manipulate it, it's kind of a downside. Partitioning that we have now doesn't completely, make it like blind to that problem, but it certainly goes a lot farther in helping it. But that was sort of the state of things before 8.1. What 8.1 gave us was constraint exclusion, and that was basically a way for Postgres, when you write a query, to do that knowledge of which partitions would actually have to hit, and sort of cut down on a whole number of issues as far as like scanning the super large tables and being able to drill down only to tables you need. So that was sort of the big thing. 8.1, I think, was the watershed moment where people actually felt like you could call this partitioning and it was a real system. Since then, there haven't been a whole lot of changes. 8.2 didn't bring anything terribly spectacular. It brought a few things to sort of ease management of partitions. 8.3 is not going to really have anything related to partitions in it. There is talk of doing some things in 8.4, but nothing's really concrete. I mean, it's 8.4. It's pretty far out there. And I don't really know that it's going to get done, so I sort of leave that in the realm of, well, that would be nice. It would be good if somebody worked on some things. But right now, what you have is probably what you're going to have, at least for the next year or two. Partitioning, as far as that goes, 8.3, if you have big data, you probably still want to upgrade, but you're not going to get anything huge in 8.3 as far as partitioning is going. So using a little terminology here, and so since this is my talk, this is how I define these terms. And if you don't like it, you go do your own talk. So the two basic types I'm going to talk about here are range partitioning and list partitioning. And in Postgres, well, in other systems, I'll say they're generally treated fairly differently. There's a lot of different syntax involved. In Postgres, it's all pretty much done the same way, but that's mostly because Postgres leaves it up to you to do all the work. So I don't know if that's good or bad, but anyway, so we have range partitioning, and I think that's usually the classic example that most people think about with partitioning. It's just, you define a specific range of data. The timestamp is the most obvious one. You might be logging like web hits or, any kind of thing that's like sequential in time. And that's pretty commonly done. It doesn't have to be that. I mean, you can do it over a range of numbers. You can do, like, if you have a user ID that's like a serial field, and just under like 100,000, you can put it into its own partition. I don't know if that's really a good idea, but I mean, that's one way you could do it, depending on how you're doing things. So that's sort of the idea of range partitioning. List partitioning is more of a static defined list, hence list partitioning, where you kind of know all the sets of values and it's not going to change a whole lot. State codes is one I tend to think of, right? So say you want to partition your data against all the 50 states. I don't think we're going to add any states anytime soon. You know, maybe. There's talk, but but you can be pretty sure that if you define, like, well, here's my 50 partitions, and here's my list, and I'll set my constraints on that, that's pretty much a well-defined set. You can also do things like, I put user ID mod 3, or you can use, I think there's a function called hash text, which like takes text and does like an integer hash of it. So you could use something like that, and then sort of define the range of values that those particular things would go in, and set up a specific list of partitions for that. So, I mean, there's other ways to do list partitioning, but it's just that basic idea. When I say list partitioning, I'm talking about a pretty static and well-defined list of items that you're going to dump things into. And it's not going to increase. You're not going to have to worry about sort of ongoing maintenance of those partitions. So, question 1, should the table be partitioned? Right. Like I said, there's a number of questions you have to ask yourself. The biggest issue being that you're going to add some complexity into your database if you do partitioning. And that's mainly, or hopefully you can do that in a way, it's like whoever is designated your DBA or your guy that works on schema, you know, it's something that that guy has to deal with. And if he thinks it's a problem because he doesn't want to deal with the complexity, you could try to tell him it's like job security because it'll be stuff that he has to deal with. He still doesn't like it, get a new one, I guess.
Or call on MTI.
Or call it MTI, I guess. So there is also some administration costs that go into this, especially if you're doing range partitioning, where you have to keep creating partitions to deal with the new ranges. So there is that as well. But generally, I mean, most people find that it's worth it in the sense that if your data is going to grow and you're going to be doing like astronomical numbers of data, I mean, you got to do something. So, you know, this is the tool you have. So look at a little bit of syntax here. I mean, syntax I find generally to be pretty simple and straightforward. Here we're creating a master table, which will be what all the other partitions are defined from. This is where Postgres really differs from other database systems. Most systems that you look at that do partitioning have a really specific syntax for creating a partition table. And it's usually a bunch of extensions into the create table statement. But here, we would just define a master table pretty much like anything else. Here I'm doing payment table. I've got a payment ID and a couple of foreign key data amounts and the amount that they're paying. And then a timestamp, which we'll use to do the partitioning on. Does anybody notice anything funky about this table?
How come you're using timestamp without time zone?
Because I don't want to use time zones.
How come you're using small numbers for the payments?
5-2?
Yeah.
Because we don't charge our customers on our internet.
No constraints.
So the one funky thing I was thinking, because we're in a room full of database people, was I didn't actually declare a primary key on this table.
Well, how could you? You're going to partition it.
Well, exactly, right?
You're not supposed to know what's coming.
So that's one of the trade-offs with partition tables, and I'm going to discuss it more as we go through this. But you kind of have to give up on the idea of having like really pure primary keys, and that's really a pain in the butt. And I kind of hated to do it. The original scheme of this was payment ID was a primary key, and that was nice, but it isn't anymore, so it's not as nice. Some people get really offended by that, but you just got to deal with it. So I'm letting you know now, right? No primary keys. There's kind of some workarounds for that, and we'll hit on that. So here I am, I'm making a child table, and this syntax is a little more, or a little less frequently seen, so it might be a little more confusing. The first thing I always try to stress to people is make sure you do a simple naming scheme for your partitions. Here we're doing ranges, and they're month-based, so it's like partition 2007-02. That's for February, right? Pretty simple and straightforward, and you can pretty much guess what all the future or past partitions might be named, hopefully. So that's why I like to stress that though, because I have seen some partition schemes where, I don't even know where they came up with the names, or like if it's on month, and they'll call it like 02, like _15, right? Because they're partitioning every 15th day of the month or something. And to me, that's just like completely crazy. Unless you're doing it a check constraint where it's going to be down to the day level, then it would make sense. But if you're doing it on the month level, try to make it obvious that it's at the month level. So the next thing here that you see is we set up non-overlapping constraints. Here, I'm just setting my date ranges, right? Notice I switched to 03 in this example, in case you got thrown off there. So this is between March and April. Yeah, some people would. Let me sure. So it's important that you have non-overlapping constraints. One of the things that I guess I would sort of say is probably a deficiency in Postgres is that with this implementation, there's nothing stopping you from shooting yourself in the foot. Right? So I could have actually made 02 with the same constraints as 03, and Postgres wouldn't say anything. You'd realize it later on, but you know, up front, you're not going to get told that. So when you're doing this, make sure they're not overlapping. And I've seen times where it was just a simple mistake where somebody was doing like some copy paste, so they went to do 04, and then they went 03 to 05, right, for that partition, and now you've got a problem. So just be aware when you're doing that. But that's how that's going to work.
Do you generally generate those, like with a
I do. The other thing, so all columns in these tables come from the parent, right? And that is another thing, I think maybe it throws people off the first few times they're going through it, is that you don't actually declare any columns on your child tables. So you're not declaring any columns in your partition. So just inherits payment. Payment is the master table. All columns come from that. And that's basically it for the basics of making a child table. You need to do that for all the ranges that you're going to have. And we'll hit on how to make that a little easier. One thing I also want to stress though is make sure you match your data types for the type that's in the column. Here you can see I did like payment date, and to do a month, there's no like month data type in Postgres, which is fine, that's cool. But since we're kind of doing it by month in the table for our partition range, we are specifying a day down to the day. But more importantly, the payments are coming in, and there are actual timestamp values. So they're going to have a day and a time in them, right? And we want to preserve that for the actual data. But for our date range, we want to make sure that Postgres doesn't look at 2007, 04, or 01 and think it's a date when the data in the table is a timestamp. This won't break anything if you do that, other than it probably will break some things as far as making your queries and getting them to perform well. So that's why I say make sure you match those data types, because then you start to have like performance issues where the query planner is not doing what you think it should. In theory, you could probably get into worse problems than that. So it's another one of those like big, make sure you're watching for that.
It would make sense to have a stored procedure or something like that that sets up petitions for you.
We'll get there. If you're going to do some other things, like foreign keys you may want, in that particular payment table, right, so we have like customer ID and rental ID and that kind of stuff, and ideally you'd like those to be foreign keys off to other tables. The problem that you have is when you make a table as a child table that's inheriting from a parent, no matter what you've declared on the parent, the majority of that stuff is not carried forward on the inherited child table, right? So you've got to set all that stuff up yourself. It's not that big of a deal, but it is more work that you have to go through. And you have to make sure you do it for every child table, and it's not, again, it's one of those things where you won't get errors. You might open yourself up to some kind of corruption, like if you forgot them on 02, then you could put in like a bogus customer ID in theory. Right? It's kind of odd to think that you'd have a problem with that, but I mean, foreign keys are there for a reason. So anyway, so that's sort of what the syntax looks like for that. If you're going to do indexes, again, those are not carried forward from the master table either. So you've got to use commands to set that up on each of the child tables. Using indexes on child tables, a lot of people think there's not much need for it, but I've seen, if you're going to do like bitmap joins, it can be pretty handy because even though the query planner will get you down to the right partition, if you're querying maybe across like 3 partitions and then you have indexes on those 3 partitions, it can still take advantage of that and bitmap join across the 3 partitions. Right? So there are some like querying that you may want to do. You're not only doing it on the partition key, you're querying with the where clause on other fields. It might still be good to have indexes in there, right? And then I know at the bottom it's just rinse and repeat for each child. You have to do this, both the constraints and the indexes. And if people are hinting at like, hey, we should automate that, so you probably want to. There's also, if you're going to do rules, how many people here use rules on their partitions? You. How did you do that?
You know better.
You don't. Well, you're here now, so you'll learn. So if you look at the docs, it tells you to use rules. And for now, I'm not going to patch that, but give me 3 slides and I'll be there. So we're going to use, right, so it's just, how many people are familiar with rules in general? Like most people understand how that works. Okay, so you can see the syntax is pretty straightforward, right? You just make a rule to redirect, so you try to insert it into the payment table, and we're going to instead insert it into the proper partition, right? That's pretty straightforward. Where clause for the date range, blah, 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 put the new data in, that's great. Again, you have to do this for each child. You make a rule for each child table, so that no matter where they're trying to stick the data in, it goes to the right spot. Good. Yeah. So this starts to lead to a lot of rules on here. I had to shrink this down so you can see the table was like here, this block here is all the rules that you have. And you know, that's actually the fairly simple version of that. Because you also have to do the rules for updates if you're going to be updating the data. A lot of people don't have to deal with this on some level. Like if you're doing like, you know, hits on your website or something, you probably don't actually have updates to those records. You know, but on the other hand, you might still want to deal with it in some way, because if somebody does run an update on the table and they expect it to do something, it might be nice if it did. You know, even if that's like raising error. But so you also have to make a rule for updates on each child.
Well, that rule doesn't appear to handle the case where like the update would load the record to it.
Yeah, it doesn't. Don't do that. Right. Don't use rules. So you also have to do it for deletes. And so here's what a delete rule would look like. And I really greased through this because I mean, it just, to me, it's, well, we'll get to that. So you really this is what your screen is going to look like if you start doing this. So, I mean, just imagine like that idea. The table we have like 1,700 partitions, right? If I had to do insert, update, and delete on that, that's like over 5,000 rules in the system for the one table. And that's just, it's like, you know, to me, it's not right. So, you know, this idea, you know, managing partitions with rules, right? Well, it doesn't. It really sucks if you're using rules. And it's not bad. I mean, if you're on a small system, or, you know, you've got fairly well-defined things, there are some good things about rules, I guess. I will admit that on our large, like, terabyte level system, I have tables that still use rules, because the guy that was there before me set them up with rules. And when I got in, I replaced a bunch of them. But yeah, there's some that like they work and the performance is okay. And those are ones that are not, you know, every day we're making a new partition. Maybe we're doing it like every 3 months or something. And so, you know, probably eventually I'll still end up replacing them. But at this point, I just leave the rules there because it works and, you know, I'm busy. So, but if you think about managing with rules, so here's sort of the reasons why. If you're using rules now, you might want to look at not using rules and using triggers instead. As I noted, right, you get a large number of rules, the more partitions you have. Big one. Rules require a lot of overhead. The more you get, the worse it gets. One thing to remember with rules is that as it evaluates each rule, right, it has to process those. So that can lead to really weird things. And usually when people realize this, it's because they get bit by something, like a function that's really expensive that they'll use on a table when they're doing a select, and then they'll realize like, oh, that function just got reevaluated like 20 times as it was filtered down through the different rules. And that sucks, right? I think you probably ran into that in the past. Right? I think people generally hit that eventually. So that's like one of the bigger problems. Another big problem I have with rules is if you want to add or remove them or change them, you need an exclusive block on the table. And anytime you need an exclusive block, that's a problem. Triggers can sometimes be a problem in that area, but it's not as bad as with rules. Because anything you're going to do to a rule is going to require that exclusive block. So we'll touch on triggers a bit here. But those are some of the things that are a problem with rules. And also, as the number of rules increases, again, performance is going to decrease. And that's sort of a thing you probably want to avoid.
He's being polite. It's excessive. I mean, it's wrong.
Yeah, it's really bad. So,
It's not in login.
pardon?
In login.
It's not in login.
It's probably worse than that.
It's nasty. It's just the fact that it's in the docs is an embarrassment.
Well, actually, the rules method works fine when you have a very small number of partitions.
Yeah, I think like if you're doing list partitioning, it's a better case, right?
For example, well, I had an application where you had a historical data partition that was immense, like a terabyte. And then you had an active data partition that was a little tiny, gigabyte partition where data was actually being modified. And for that partitioning scheme, rules were great. There's only 2 partitions.
I'd say they work okay. So, managing partitions with triggers. You don't have to use rules, right? You can also use triggers. And I think this is generally what I recommend to folks. Triggers actually give you some flexibility about how things are going to be done as well. And that's a good reason to look into them. You get better control, right, when you're using triggers. One of the things to think about is with rules, they're actually kind of magical in a lot of sense. And I think, external programs in general, and I think developers in general, don't really understand how rules work and how that whole process actually works. But triggers are something that are fairly more well understood within the industry. And also within Postgres, you can be more flexible with what a trigger is going to do, right? Rules are pretty good, and they can pretty much accomplish everything that you need, to at least get started. But triggers, and more importantly, the functions that the triggers are calling, can become extremely flexible and do all kinds of crazy stuff. Another good thing you can get is consistent performance using triggers. Even against range partitions, you can get that. It's not always the fastest way to do it, depending on how you write your function, but you can get it consistent. So in the cases where consistency is important, and I think that's most of them, functions and triggers are the way to go. Also, modifying the trigger function doesn't require any special lock on the table, and that's sort of a big one. You will need a lock on the table to get the trigger in place, but after that, if you want to modify what the function does or how it operates, say you want to add additional clauses in your function code, you can do all that behind the scenes. It's like create or replace function and you're good. And it works fine. You don't need any extra locking on there. And I found that's pretty huge, especially when you're dealing with a large number of partitions or you're trying to debug something or just any of that stuff. The fact that it doesn't need locking is a really big plus. There are some issues that you do have to deal with. It's not like a panacea. It's probably more complicated on some level. If you take what's in the docs and use rules, more or less you can do copy paste and work it out. You do actually have to know how to do some function programming on some level. So I don't think it's overly complicated function programming, but if you never touch PostgreSQL, there's going to be a little bit of a barrier there. But by and large, it's probably better.
You could just write it in PLPHP.
That's what
If you've never touched PLPGSQL, you probably shouldn't be using partitioning anyway.
I wouldn't necessarily argue that statement either. So here's what a typical trigger function will look like. And it's, to me, again, if you use PLPGSQL, this is not really crazy. This is just to do the insert bit, right? And it's just this idea of when you do the insert into payment, and because we're doing a range here, and it's fairly easy to figure out what the next one's going to be, I can take a date visit, right? Figure out which month that would actually go into, and then redirect it into the right table. And then I run an execute on the SQL string that I've ended up building in that. And what's nice about that is if you build a function like this, right, it handles any date that you're going to throw at the table. So no matter how many partitions you end up creating, you're pretty much done once you have this function in place. With rules, every time you make a new partition, you have to add the new rules, right? Now, it's not like a golden rule or whatever. You got to handle updates and deletes and inserts if that's what you need on your table. But even those are it's another chunk of PLPGSQL code, which is basically just doing the specially escaped string building. It's not that crazy. And then again, this works with create trigger in order to set this up. So it's not too much. Here again, we're doing the partition date on the fly. So that works pretty well. Do an execute. This is the low maintenance option.
What kind of overhead is there for piling a string of SQL together at each row? And
part of that will depend on how crazy you need that to be, right? So for this, I'm not going to say it's not a lot of overhead. It can be significant depending on how many rows you're inserting and all that. Again, you're basically doing an extra, you get the trigger call, the trigger's going to call the function is going to run the SQL internally to build the string, then that's going to execute the SQL to get it into the right table. And it's a lot more overhead than what you'd have with a rule, right? I don't know percentage-wise, it's not like, oh, 20% worse or anything like that. But it's certainly more overhead than what you have. The big bonus is it's consistent though, right? No matter how many partitions you add, if this is fast enough for you, it'll always be fast enough for you, right? And that to me is a huge one that you're not going to have to deal with, that you will have to deal with rules eventually if you get down that far. So that's sort of the one way to do it. The other way to do it, I should mention that. So one problem with this method is if you have to deal with nulls, the quoting and dealing with nulls can be pretty painful. And I've had to do it, although if I threw the example up on the screen, it wouldn't fit. So basically it's a problem that you have to check every column that comes back and make sure that it's not null, or if it is null, make sure that you have the quotes on or don't have the quotes on, depending on it.
Couldn't you use the
Custom operators.
Okay. But I guess that would work.
Yeah, no, because like one of the, I think I actually put it on a general bit somewhere too. Just run a simple custom operator that does the comma, it does the quoting, and it handles nulls, which is easy enough to do, and then you only have to do it once.
There you go. So that would certainly be a better way to handle that then. So that would be a bonus. It's still a little bit of pain in that you'd have to make the operator, but and I guess you possibly have to do that for each data type that you have to deal with.
Yeah.
With integer values, it doesn't matter, but timestamps and text and things like that, you have to worry about that. And the big problem being, just so everyone understands, is if you try to concatenate a null into one of these fields, the whole string turns into a null, right? Because null plus anything becomes null. And then when you execute it,
Where's all my data?
yeah, doesn't actually do anything. If you're lucky, I think it'll cause an error, right?
Otherwise, it'll just run a lot faster.
So I want to show the other version of making a function. And this one, so the difference that we're doing is in the previous one, what you saw was me building a query string and then executing that. And that worked for every value that's out there. The problem is it's slower because it has to build the query string and then execute it. So you can actually write a function though where it doesn't have to do that, where it sort of catches the query plan, when you make the function. And here what I'm doing is, I'm tossing in if-then statement, looking at the date range that I'm dealing with, and that's pretty similar, but instead of building a string, I'm just executing straight SQL, right? So that's pretty handy in a lot of ways.
Except that you've got to spin through all of those.
Right. So that's where the problem comes in. You need to add a condition check for each partition, and that can be a pain. So this is sort of the maintenance versus the speed. This way will be faster if you do it than the last way that I showed you, but it will create more maintenance overhead.
It'll be faster in January, but will it not faster?
And that kind of depends. And depending how smart you are when you write the function, right, you can deal with that to some effect. But it will get slower as you have more things that you have to go through. But you can also do them in reverse order, in a sense, because you can always put the most recent date as the first one that you're going to hit, and then sort of go slower. For inserts, that's fine. For deletes and updates, if you're doing a lot of deletes and updates, it's not going to help you as much. But even still, usually your more recent data is what you're dealing with.
Couldn't you shorten up the comparison by doing one sort of map at the top to the month and then test for equality?
If you want to. Yeah.
And we're really not talking, yes, it would be faster, but we're talking about a minute amount of time to evaluate each of these conditions.
Yeah.
That's not even if there's 100 partitions.
The overhead of comparing, each different if condition, it's not necessarily, it's less than it would be to evaluate a new rule. And the speed bonus you get from doing the SQL directly as opposed to making a query string and executing it is pretty significant. Right? So I don't necessarily have any benchmark numbers, but I think this would probably outperform rules on a large set, let's say 100 partitions or more. I would guess that this method would do it, would outperform rules on it.
I would agree, because you're only evaluating a condition versus firing each rule.
Right. And again, you can do little tricks on, trying to make sure that you evaluate the right one at the right time. To be honest, even something like this, right? Well, there's a couple issues with doing it this way as well. But you're probably going to end up trying to pre-generate this code anyway, so how ugly it looks or whatever isn't necessarily a huge issue. You can put sort of that logic in there so you're not really thinking about it all the time. Set something up once to build it for you. That's what we do. Also, I like to throw in something, and this is how I do it, although you can raise an error if you want. And that's sort of one of the nice things about triggers again. But here what I do is, if I don't find a matching condition, I throw it into my parent table. And the reason I do that is, like, I have a Nagios check that looks at all my parent tables and sees if there's any rows in them. And if there is, then I know something broke. Right?
So I thought that this was the case in 7.4, but I thought that if you put rows in the parent table, it would actually appear in all of the child partitions.
I don't think that's
What did he say?
If you put a row in the parent table, it will appear in all child tables.
When you query each individual child partition.
No, if you do a select only, it's not going to appear there.
Right, without a select only.
Oh, without a select only.
Yeah.
If you select from the parent, it will appear. If you select from the child, it's not going to be.
It won't appear. But here's what I think you might be thinking of, and this is actually true, that what will happen is if you do a select and the query planner says, I only need to pull from this partition, it'll go to that partition, but it always also grabs rows from the parent. So even if you say, like, I only need something from like 3 months ago, if all your current rows are in the parent, they'll come with it, and it'll scan over all those rows as well. So that's how I know something is broken, as I say, right? Because these rows, they wouldn't show up, and these old ones are going to because they're in the parent.
Why not create a garbage partition instead of putting it in the parent?
The parent is the garbage partition. That's how I look at it. Because really, you never want any rows in your parent.
Right.
I mean, that's sort of my philosophy is you never want any rows in your parent. So if any row ends up in there, to me, I throw an email and I get paid if a row would show up in my parent. So other people, I know, you can also, you can just toss an error outright and say, you know what, I didn't find a matching partition. This is an error condition. You can use, call a DLTCU function and, throw an email to yourself right in the trigger. There's a number of ways you can deal with that. And that's the way that I do it. And for me, it's pretty easy to set that up, and then it's basically like look at all the parents and find if there's any rows. So that's how I do it. But you need to deal with that sort of, hey, I didn't actually find a condition. And it's something to think about in all of these cases. This does get to be kind of high maintenance, especially when you're doing it against a range partition. And the reason being that if you're doing daily, then that means every day you've got to go in and add a new thing. That's kind of a pain in the butt. Also, you can get large, if trees like we were saying. If you really know your data, though, I have one setup that actually does this because I need the performance. But I have a cron job that goes in and it rebuilds this function every day and it covers a range of about, I think, like 4 days for it, right? And it's like one of these where I'm just logging web hits. And it rebuilds the function every day. And what I do is I actually prune the list every day, right? So that I know I wasn't going to get anything older than 2 days in here. I won't get anything newer than 2 days. So I keep it to like 4 blocks that it has to evaluate, and that's it. And I do them in the proper order of how you should actually come in, right? So you can set that up, and that's just a PLPG-SQL function that rebuilds this PLPG-SQL function, like every day. So you can set all that stuff up, and you can automate it. But it is something you kind of got to deal with. You certainly don't want to go in there and like manually hack this every day. If you're doing daily partitioning, if you're doing it once a month, you don't want to hack it every month either, right? So, I'd encourage you to go and figure out a way that you like to use to automate any of these processes. And again, if you're using like simple table names like we do, it's based off of fairly easy to deduce things. All of it's pretty straightforward to code and automate. And it's a big kind of bonus that way. How much maintenance all this stuff is and how much you have to deal with, it really does depend on if you're doing list versus range. With the range one, like I said, that one's high maintenance. If you're doing a list where you define like, hey, I've got 10 partitions, that's all I'm going to ever have, then that previous method is fine because unless something drastic changes, you don't actually have to go in and deal with that function anymore. So again, hash, or states is like a list, dates and serial for the range. The defined set and the ever-increasing set. One thing also to keep in mind when you're doing this list versus hash, when you have a list, generally the data per child grows, right? As you get more and more rows, the number of actual partitions you have is the same. So all those rows just get filtered into their partitions, and the data in each partition grows. With range, it's sort of the other way around, right? The data per child is static, and it's the number of partitions that are growing. That can affect you in different ways from a maintenance standpoint. It just, kind of depends on what you're doing. Where did that go? Again, here's another one where if you got a list, it's fairly static query patterns, because the queries always go into one or the other, partition. With range, it's volatile query patterns, so you have to sort of be aware of that, especially if you do things, and you can do this in Postgres, which is actually pretty handy, like querying into specific partitions when you know that's what you need to deal with. I have one cron job that we fill the partition table going from an Oracle system, and so what we do is, and this is another one of those functions I rebuild every day. Hey, you, where are you going? We rebuild every day, and it just goes and it queries the Oracle system and it dumps all the day's data into a partition on Postgres. And so we rebuild that every day. But you have to put in the smarts to know, like, hey, that child is going to change all the time. So, that's what we do. I generally think list partitions are lower maintenance, at least as far as what you have to deal with. Range ones are higher maintenance, but I think they're the more common use as well. So, just be aware of that. Those are sort of things to think about as you're setting this up. And thinking about the scope of the work that's going to be involved, either creating rules if you're still foolish enough to do that, or making triggers and functions and things like that.
Don't hold back. Tell us how you really feel.
For maintenance, remember, deterministic partitions are easy to deal with. That's the timestamp. That's the serial ranges. Like, don't do it every 777 once. Even if that's deterministic, it's still bad because it's hard to do the math. You're like 10,000. But anyway, so deterministic ones are the key. Rules, triggers, and functions, these can all be dynamically generated. It actually doesn't matter which one you're doing. You can always recreate these things on the fly. The locking is the only thing you really have to deal with. And functions are the best in that case because they don't take any locks on anything. You actually don't have to have a complete partition structure. And this is one that sort of throws people, you can have holes in your partition ranges if you don't have data for those partitions for some reason. I won't go into too many reasons why that would be, but it can happen. And if it does, that's okay. It's not a bad thing. It can throw you off, but if you don't want to create a bunch of empty partitions for some reason, then that's okay. Generate series is kind of the key to automating everything. It's your friend. I'll show you a quick example here of how you use generate series. So everyone here knows generate series, right? I'm assuming you're all hip to that. So here you generate a series of 12 rows. You can then take that and with a little bit of SQL foo, right? You can generate a list of all the different months, right? And you can do this with any interval. You can do it with days or weeks or whatever you want. No big deal. So here I took the next step and I generate my table names. So this is if you're going to automate children that you're building, this is how you would do it. Right? And you can figure out, so actually in this particular query, what I do is I generate all the table names and then I do a not in and I select back to see which tables I've created. Right? So I know all the ones I need to create in the future. Right? Or if something is broken, I can go look and say, oh, these are the ones that should have been created. You can do this on rules if you need to. It gets a little uglier to do this with functions. Yeah. ProSource and VGProc is your friend, I guess. So you can also use this to figure out which rules you need to have created. This can actually be good after the fact. If you didn't think you needed to handle deletes and suddenly you do, you can go pre-generate all the rules that you're going to need. Or figure out things that you want to delete. If you're going to drop old partitions, right, you're doing that 90-day cycle thing. Every day you make a new partition and you drop the old one 90 days ago, you can use the same kind of SQL to figure out, oh, here's the ones that are older than 90. I'll go ahead and drop those. Deja vu. So, I don't know where that came from. So there are a few other things just to mention to be aware of. And this is sort of the big one. Early on, I noted that table didn't have a primary key. Primary keys and unique constraints really cannot be enforced properly with partition tables. And it's sort of a problem on some sense. It does mean you can't actually have a foreign key where the parent is in the child table. There's no real workaround for that at all. To get around the primary keys and the unique constraints, the thing is, right, Postgres uses indexes to define uniqueness, and Postgres doesn't have indexes across multiple tables. And since each partition is actually a table, you're pretty much out of luck. If you need to index the partition key, or if you wanted that as your primary key, or you wanted a unique constraint on that, you can get pretty good using check constraints to get you into a range, and then putting a unique key on each table, right, each child partition table. In most cases, that will guarantee uniqueness. It's pretty hard to break that. I wouldn't say it's impossible, but it's pretty hard to break that. So you can kind of get unique constraints if you want to.
If you have non-overlapping and then uniqueness inside, you're pretty much done.
Pretty much done, yeah. So, I mean, that's kind of the way. And until a multi-table system comes, that's pretty much what you have to do. So just index each partition, and that probably works. Where you have a problem is if you're trying to do a unique constraint on something that's not your partition key, because then you really have no way to deal with that. I wouldn't say no way, but right, there's no good way to deal with that. You can still do the index per partition, so you can make sure that each partition is unique amongst itself. I guess that's better than nothing, but it doesn't guarantee uniqueness across the partitions, and if you really need that on two columns, you know, it's a problem. Some would say it's a big implementation hole. You can get around it. Use something like a function, right? Because you can make a function to query across tables and make sure that it's unique in all the partition ranges. And the big problem with that is just that, you know, the whole reason to use partitions is because querying across all the partitions is too cumbersome to be realistic. So making a custom function that'll do that for you is going to be a pretty big performance hit. But if you really need it, I mean, there is a way to do it. You don't have much better news than that. I think it's just an inherent problem with multi-table indexes anyways. Even if Postgres could do it, if you think about, you know, I'm going to make an index across 2 billion rows, you're not going to make that fast to scan. Even if it's all done in C code in the back end, you know, no matter what, it's not going to be like super quick. So it would be better than this, but you know, it's still 2 billion rows, and that's a lot of data. So I did want to mention a little bit on querying partitions. And this is usually, I think, the real answer is just make sure you test your application and make sure you run explain analyze on the queries you're dealing with. Because it can be tricky to get it right. The biggest problem that you find are data type issues, right? You need to query on a static value, and it's got to be Postgres' definition of static. So if you query like everything where the timestamp equals current date is not static. It's actually could change. You could change your time zone, and that would change your date possibly. So Postgres won't take that as a static variable, right? Static variable as a static value. So you can get around that if you're doing like functional programming. It's pretty easy. Even in any app language, you just need to know if that's what you're really going to do. Generate the date value ahead of time, and then pass that in as like a static date, right, for current date. It's sort of a two-step process, but that's what you got to do. Test it. That's really your only way to be sure that it's going to work. I've seen things where it just like it's not obvious to you if you don't test it. Like integer versus big int is one that I've seen some odd things around that. So it's just like I said, make sure you test and use explain analyze to make sure you're only hitting the ones you want. The worst example of how this works is actually doing booleans. And I did this one day. I just like stumbled across how bad this was because we were making one of those like ticket ones, and I was like, well, why don't I make like just 2 partitions? This will be awesome. I'll have one for like active tickets, and then I'll have another one for closed tickets, right? And all the closed ones will go in their own partition. Put that on slow storage. It'll be awesome, and I'll be the man. And like I could not get it to work for the life of me. And I spent like 30 minutes or something just building it, and it seemed like it was all wrong. And I got an IRC, and I started talking to people, and like everything they said was all wrong too. And it was just like, what the hell is going on? So this is sort of the basic example that this looks like so straightforward, right? I'm just going to do it on a Boolean field. In the 1 table, it is B is true. In the 0 table, it's B is false. 1, 0, very obvious and simple. I set constraint exclusion equal to on, because you have to do that for constraint exclusion to work. And I throw it up here explicitly because you would think it's not on when you actually run queries against this. So here's my explain plan. And as you can see, it sequentially scanned every partition, right? And I did like where B is true. So you're kind of thinking like the filter B is true probably would match the constraint that the value is true. But it doesn't, right? Because if it did, we wouldn't actually look at everything. So it's really odd.
Just B.
Right? And if you try like not true, you have the same problem. Right? I mean, I played with a bunch of different versions of this. They were not B, right? Because there's a bunch of different syntaxes that you could use. And it really didn't matter. Whatever I tried to do on this particular table, it just absolutely would not work. And I thought, this is a bug or something. It probably is, but it certainly seems like a deficiency. So eventually, after playing with this for a couple more hours, and yeah, there was nothing good on TV that night, so I'm going to figure this one out. I ended up coming up with this, and this actually works. And you're like looking at this like, wow, this is the same thing that I just did on the other one. It's just ever so slightly different. Here it's the same, table X, B Boolean. But here, instead of saying like B is true or B is not true, I just say check not B or check B. And it's so magical that this one actually works. All right. So here's the one for is true. It does work, but you have to query it the right way. So here's where I query like where B is true, right? And that does not work. But at least I can do this, right? I can say where B, and then it works, right? I always sequentially scan the one table, and my parent table, and then the true table, and I don't look at the false one. So after doing this, I actually said I'm not going to actually ever partition on booleans because it's so nasty that where B is true doesn't work, and where B does work. It's just crazy. So this is the worst example. Nothing else will ever be as bad as doing it on booleans. Even with dates, with like the current date issue, or doing like a timestamp versus a date, like those are at least like somewhat straightforward. This one completely mystifies me even to this day. Even though I have the example that I know I could get it to work, just stay away from it because it'll never be obvious. That's pretty much it. So just test.
What you got when B not B?
When not B, that works.
That work?
Yeah. So yeah, for this one, if you put where not B, that one worked as well. If you put where B is not true, that would not work.
Yeah, it may actually be, does like work?
Or equals?
No,
Equals did not work.
I'm thinking about specifically the text operators. So I'm wondering if like works.
Like might work, but that would be a total bastardization.
One thing
I
that
think
you
that's
learned
range partitioning based on
was using things like date.
Everything's range partitioning based on like.
You can't use date. You
That was-
can't have check constraints. As a note, if you're doing date type partitioning, you can't do something like have your check constraint call on the value of a month based off of the date part function.
Oh, right.
That will not work. I stayed up late for 2 days straight once because of someone that wasn't me fixing that problem for someone.
Yeah. I mean, you'll notice all the examples I did here with the dates, like I pre-generated a static.
Use
date.
a real
So
constraint.
that's, I mean, you really have to deal in like completely static things. For Postgres' version of static, not your version. So just test those queries. I mean, you can work them out. You just gotta test them to make sure they're gonna do what you want.
Did you ever test like multiple levels of inheritance as far as the partitioning goes?
I have. It works okay. I guess I haven't had a use case for it in a production system where I really wanted to do that. And that one probably goes back to complexity. That nesting inheritance is not easy, I guess. It's not hard, but it's easy to trip yourself up when you go in and try to debug something. So that's it. I guess the job is ready to go.
Yeah.